Today we are going to discuss about QNX architecture. QNX is the commercial grade real-time operating system which is widely used in industry, especially in automotive, medical and aerospace. This session will focus mainly on how QNX architecture is built and how it is different from other architectures like real-time executives and monolithic kernel operating systems. So, by the end of this class, you will be clearly able to understand why companies prefer microkernel architecture for the critical embedded systems. About portability, QNX is designed to be highly portable. It follows standards such as POSIX.1 and ANSI, C or C++. Because of this, the coding method and API structure is very similar to Unix based programming. This gives a huge advantage because we don't have to rewrite applications completely when moving QNX from one processor platform to another. It supports GNU compiler chain also. So basically QNX is a standard based RTOS with very small memory footprint which is suitable for embedded devices. In the traditional real-time executive, in older generation and all, everything runs inside the single address space. All modules like scheduler, driver, file systems, network stack, everything is one big combined program. The problem with this approach is if one module crashes, the entire system fails because everything is tightly coupled. Debugging becomes very hard and the reliability becomes low. Such type of executive systems are not suitable for modern complex embedded products. So we are going to discuss about monolithic kernel OS. In monolithic kernel OS, all core OS services like drivers, memory manager, file system and network stack are built into the kernel itself. So this means the kernel becomes very large. Applications run outside and it is in protected memory space. But still, if a driver or a kernel component has a bug, it becomes difficult to isolate and bug. Linux is a primary example of monolithic kernel OS. This architecture gives good performance but not ideal for safety critical system. So coming to the important QNX microkernel architecture. In the QNX, the OS is not one large kernel. Instead, it is made up of very small microkernel called proc-NTO plus many independent cooperating processes. So the microkernel handles only the core minimum RTOS functions like thread management, scheduling and inter-process communication. All other services like drivers and then file system, network stack, GUI, etc. runs as a separate user space process. So even if a driver crashes, it does not crash the kernel. This gives extremely high reliability, which is why QNX is used in automotive ECUs and medical devices. So coming to the inter-process communication. So in the QNX, all the OS services and user applications communicate using the message passing. This concept is called inter-process communication. QNX offers various IPC mechanisms. The beauty is here, that is everything behaves like a distributed system inside the one machine. Each process talks to each other through the messages. So they cooperate together and form a seamless OS. This modularity is what gives the QNX a high maintainability. So about the proc-NTO components. So the proc-NTO, which is the kernel component of QNX, actually contains two internal different parts. One is a microkernel and other is a process manager. So the microkernel is reached by kernel calls and mainly handles the threads and IPC. The process manager is reached via messages and handles the processes and memory management. So these two operate together as a single logic unit, and this is the first process in the system with PID 1. So this combination is unique to QNX. So coming to the example of OS processes, the drivers, services are not inside the kernel. They are separate processes. For example, disk driver like DevBe8, network stack like IOSOC, character drivers like DevC, SER8250, GUI components like a screen, and various system daemons like cron, SSHD, etc. All of these are processes. So if one of these fails or needs to be updated, the kernel remains untouched. This drastically reduces the system downtime. So coming to the trade-off about the architecture. So this architecture gives a huge benefits like reliability, reconfigurability, easy debugging, and then scalability. So developers can easily update or add drivers without recompiling the kernel. But there is a small cost because everything communicates through the message passing. There is more context switches and more data copies. So overhead increases slightly. But in safety critical embedded systems, reliability is always given higher priority than minimal performance loss. So coming to the conclusion, QNX is a microkernel architecture (RTAS) where OS services are delivered by separate cooperating processes. Drivers are not inside the kernel, but they run as processes. Threads run code and resources are owned by processes. The operating system supports preemptive scheduling, which is necessary for strict real-time behavior. So in industry, especially if it is automotive, this architecture provides robustness and safety, which is why QNX is considered one of the best RTOS platforms. Thank you for your valuable time.